Welcome, everyone. I'm excited to kick off our presentation today. The topic is simple equations. We'll explore some fundamental concepts that are the building blocks of many mathematical ideas. Over the next few slides, we'll look at how these simple equations work and why they matter. So let's get started. All right, let's move on to slide 2, which covers the contents of our presentation. Here, we have a structured roadmap of what we're going to explore together. We'll start with a simple equation, which is the foundation of everything we'll discuss. Then, we'll look at how to set up an equation, understanding how to translate real-world problems into mathematical form. Next, we'll review what we already know about equations, making sure we're all on the same page. Moving forward, we'll clarify what exactly an equation is, emphasizing its key features. After that, we'll dive into various exercises, like exercise 4.1, to practice setting up and solving equations. Then, we'll explore how to move from a solution back to the original equation, which is a crucial step in problem solving. We'll also look at solving equations in detail, including more complex ones, to build our skills. Towards the end, we'll see how simple equations can be applied to practical situations, showing real-world relevance. And of course, we'll wrap up with additional exercises, like exercise 4.3 and 4.4, to reinforce what we've learned. Finally, we'll touch on some homework assignments to keep our practice ongoing. So, this outline is designed to guide us step by step through understanding, solving, and applying equations in various contexts. Let's take a closer look at what we call a simple equation. A simple equation is basically a mathematical statement that shows the relationship between two expressions, separated by an equal sign. The key thing to remember is that it has one variable, which is the unknown quantity we're trying to find, and the equal sign that shows the balance between the two sides. For example, in the equation 2x, 4 equals 2, we can see that the left side contains the variable x, and the right side is a constant. Understanding these simple equations is fundamental because they are the building blocks for solving more complex problems later on. Throughout this presentation, we'll see how identifying and solving these equations helps us develop critical problem-solving skills. Let's look at Amina's example to understand how we set up an equation. Imagine Amina asks Sarah to think of a number, but Amina doesn't know what it is. It could be any number, 1, 2, 3, even 100 or more. The key idea here is that since Amina doesn't know the number, we represent it with a letter. Like X, you could also use Y or T. Any letter works. The important part is that this letter stands for the unknown number Sarah is thinking of. Now Sarah takes her number and multiplies it by 4. That gives us 4x. Then she adds 5 to that product, resulting in 4x plus 5. Notice that this expression, 4x plus 5, depends directly on the value of x. For example, if Sarah's number was 1, then 4 times 1 is 4, and adding 5 gives us 9. So if x equals 1, the result is 9. And if Sarah's number was 5, then 4 times 5 is 20, plus 5 makes 25. So when x equals 5, the expression 4x plus 5 equals 25. This illustrates how the expression we create, 4x plus 5, changes depending on what number Sarah is thinking of. This is the foundation of setting up an equation, using a letter to represent an unknown, and then expressing relationships involving that unknown. It's a powerful way to translate real-world problems into mathematical form. Let's take a moment to review what we already know. The term variable refers to something that can change or vary. In other words, a variable doesn't have a fixed value. It can take on different numbers. Usually, we represent variables with letters like X, Y, Z, L, M, N, or P. These letters serve as placeholders for numbers that can change. From these variables, we can create expressions. Think of expressions as combinations of variables and operations, like addition, subtraction, multiplication, or division. For example, something like 2x plus y is an expression formed from variables and operations. The key idea here is that the value of an expression depends entirely on the values we assign to the variables. So, if we change the value of a variable, the value of the entire expression changes accordingly. This concept is fundamental because it allows us to model and analyze situations where quantities are not fixed but can vary under different conditions. It's a building block for understanding more complex mathematical relationships, which ties directly into our overall theme of exploring how variables help us understand change and relationships in various contexts. So, what exactly is an equation? Well, in an equation, you'll always find an equality sign. This sign is really important because it tells us that the value on the left side, which we call the left-hand side or LHS, is equal to the value on the right side, known as the right-hand side or RHS. For example, consider the equation 4x plus 5 equals 65. That's a typical example you might see. Here, the LHS is the expression 4x plus 5, and the RHS is just the number 65. Now, it's crucial to understand that if you see any other sign besides the equality sign between two expressions, then what you have is not an equation. For instance, if you see 4x plus 5 is greater than 65, that's not an equation, it's an inequality. It actually tells us that the value of 4x plus 5 is larger than 65. Similarly, if you see 4x plus 5 less than 65, again, it's not an equation, but it indicates that the value of 4x plus 5 is smaller than 65. So, recognizing the equality sign is key because it defines what makes an equation different from other mathematical statements. Let's explore what an equation is through some examples. First, consider the statement, the sum of 3 times x and 11 is 32. To turn this into an equation, I think about what each part means. 3 times x is simply 3x. Then, the sum of 3x and 11 becomes 3x plus 11. Since this sum equals 32, we write it as 3x plus 11 equals 32. That's our first example. Next, look at the statement. If you subtract 5 from 6 times a number, you get 7. To set this up, let's call the number. 6 times that number is 6z. Subtracting 5 from 6z gives us 6z minus 5. And since the result is 7, the equation is 6z minus 5 equals 7. The key point here is that each statement describes a relationship that can be expressed with symbols. We identify the parts, translate words into mathematical expressions, and then connect them with an equal sign to form an equation. This process helps us understand and solve real-world problems more effectively. Now, let's look at exercise 4.1, specifically question 2. The question asks us to check whether the value given in parentheses is actually a solution to the equation. For part A, we have the equation n plus 5 equals 19, and the suggested value for n is 1. So what do? We substitute n with 1 and see if the equation balances. That means we check if 1 plus 5 equals 19. Clearly, 1 plus 5 is 6, which does not equal 19. Therefore, the left-hand side, or LHS, does not equal the right-hand side, or RHS. This tells us that n equals 1 is not a solution to the equation. Moving on to question 4, here we're asked to write equations based on given statements. The first statement is that the sum of a number and 4 is 9. To express this mathematically, we write plus 4 equals 9. The second statement says that 2 is subtracted from y, resulting in 8. So, we write this as y minus 2 equals 8. What's important here is understanding how to translate words into algebraic equations. It's a fundamental skill that helps us analyze and solve real-world problems using math. So, always remember when the words say the sum of, think addition, and when they mention subtracted from, think subtraction. And finally, just to reiterate, in the earlier example, since 1 plus 5 doesn't equal 19, it confirms that the value given in brackets is not a solution. This process of verification is key in solving equations and understanding their solutions. All right, let's look at exercise 4.2, question 1. Here, we're asked to identify the first step we would use to separate the variable, and then solve the equation. The equation given is x minus 1 equals 0. The key idea here is to isolate the variable, which in this case is x since x is being subtracted by 1. The first step is to undo that subtraction by adding 1 to both sides of the equation. That way, we maintain equality while moving the constant term to the other side. So we write x minus 1 plus 1 equals 0 plus 1. Simplifying both sides, the left becomes x, because minus 1 plus 1 cancels out, and the right becomes 1. This leaves us with equals 1. Now, to check our solution, we substitute x back into the original equation. Putting equals 1, we get 1 minus 1 equals 0, which simplifies to 0 equals 0. Since both sides are equal, our solution x equals 1 is correct. This step-by-step process highlights the importance of inverse operations. Here, addition and subtraction, to solve for the variable. Remember, always perform the inverse operation to isolate the variable, and then verify your solution by substitution. Now, let's look at how Adel approaches solving equations differently. Instead of just following the usual steps from the problem to the solution, he considers the reverse process. Typically, when we solve an equation, we start with the problem and work toward the answer. But Adel asks, what if we think backwards? For example, he begins with x equals 5, then applies the same steps in reverse to understand how the solution was reached. He multiplies both sides by 4 to get 4x equals 20, and then divides both sides by 4 to go back to equals 5. Similarly, if he subtracts 3 from both sides to get 4x minus 3 equals 17, he then adds 3 to both sides to return to the original equation. This process creates an equation from the solution, and by revering each step, he can actually trace back to the initial problem. What's important here is that this reverse path not only helps us understand how solutions are derived, but it also emphasizes the connection between equations and their solutions. It's a different way of thinking that deepens our understanding of the solving process, and it ties into the bigger picture of mastering algebraic reasoning. All right, let's take a look at exercise 4.4. We've got this interesting riddle to solve. It starts by saying, I am a number, tell my identity. So our goal here is to find this mysterious number. The next line says, take me 7 times over and add 50. Now, that's a crucial instruction. It's guiding us to perform some calculations based on that number. And the goal of these operations is to reach a triple century, which is 300. But there's a twist. You still need 40, meaning after reaching 300, we need to account for an additional 40. So, in essence, we're working backwards to find our original number by setting up an equation. This puzzle is a great way to reinforce our understanding of algebraic thinking, connecting the idea of variables and operations to real-world problem solving. Remember, the key here is translating words into a mathematical expression and then solving for the unknown. Let's work through it step by step to see how all these clues fit together. Now, for your homework, I want you to focus on defining what a simple equation is. Think about how these equations are structured and what makes them straightforward to solve. Next, you'll solve a few practice problems. First, try solving 3m plus 5 equals 20. Remember to isolate the variable by performing inverse operations. Then, move on to x plus 5 equals 3. Think about what you need to do to get x alone. After that, you'll solve 5 plus 7 equals 37. Again, focus on undoing the addition first, then dividing if needed. Lastly, I want you to practice constructing 3 equations starting with x equals 3. This will help you understand how to create equations based on a given value. These exercises are designed to reinforce your understanding of solving and creating equations, which are fundamental skills in algebra and will connect to many real-world problems later on. So, take your time and practice these steps carefully.